Hey, hello there, internet people watching this video. Welcome to another episode of Dr. Bob's Last Chance Garage. You might wonder, why do I say last chance? Well, it just so happens a lot of the cars that wind up in my driveway are cars that friends or family of mine have used for a number of years but now face some kind of problem that is beyond their capacity or budget to fix. I'm not a trained mechanic of any sort, but I've been working on cars of my own, working on other people's cars to help them out for, well, a number of years, let's just say that. And sometimes the cars in my driveway, I'm the last chance before they go off to the junkyard. What we're working on today, well, it was sitting in the field. It was a trade-in for a job someone had done for someone else. 1987 Jeep J20. It's got the 360 motor, the 2-barrel carburetor, and lots of vacuum lines. Today, what I'm going to do is walk you through the process of changing out and fixing those vacuum lines. Broken, misrouted vacuum lines can cause any number of problems. Drivability, performance, poor fuel economy, especially on the Jeep motors, where so much is controlled by vacuum. So, today I'm going to walk you through the old vacuum system and show you what to do to put in a new vacuum system. It's one of those things that can be daunting to a first-timer. You don't always know where every vacuum line goes, but actually it's not all that difficult, and certainly not all that expensive to repair most of this. So come along. I'll take you on a guided tour of all the elements of a 1987 Jeep J20 vacuum system. I'll show you its highlights, I'll show you its lowlights, and I'll show you where this one has been hacked by previous owners. Not a lot of fun, but the results should be rewarding. Alright, come along.
Well, here she is in all her glory. A Motorcraft 2150 2-barrel carburetor, a Motorcraft distributor, an evaporative system from a GM probably, and then back an EGR valve, and on the firewall you can see disconnected, no vacuum source going to it at all, a vacuum reservoir for running all the accessories and the heater inside the vehicle. Some of this is hooked up, some of this is disconnected, some of this is plugged off. Let's start. The most basic line every engine is going to require is the line for the distributor. This distributor line is going to be switched on and off based on temperature, and that's going to affect whether the engine receives manifold or ported vacuum. With manifold vacuum, it's going to raise the idle, which is going to help an engine warm up. After it warms up, it switches ordinarily to ported vacuum. Now, it's kind of clever how they have these switches. On other cars, they're called thermostatic vacuum switches. On this model of Jeep, most Jeeps from the 70s and 80s, they use the term coolant temperature override. That is to say, it overrides the source of vacuum based on the temperature of the coolant. Most all of them, you can see underneath here, a yellow sensor. This yellow sensor is the low temperature coolant override switch, or CTO for short. It switches between ported vacuum and manifold vacuum. It's manifold vacuum below 145 degrees or so. It's manifold vacuum under 145 degrees or so. It's ported vacuum over 145 degrees. So it has one vacuum source and then two vacuum sources, one manifold, one ported, and then the feed that goes to the distributor. Well, It's a little more complicated than that on this truck because it also has a high temperature vacuum switch. This has the heavy duty vacuum ignition system. It has a high temp coolant temperature override. Above 220 degrees, this switch will switch from ported vacuum back to manifold vacuum. The idea behind that is manifold vacuum is going to raise the idle speed. It's going to turn the engine faster. It's going to turn this fan faster. And it's going to cool off the engine better when the engine is above 220 degrees. And there's yet a third coolant temperature override switch on this system, but it doesn't have anything to do with the spark. Way in the back, there is, right down next to the EGR valve, there is a 5-port coolant temperature override system. So, I've got a factory vacuum diagram. Many cars will have a factory vacuum diagram over here next to the certification label on the front header of the vehicle. This one doesn't have it. Why? Jeep. I don't know why. So my first thing, and your first thing, ought to be finding out what the vacuum system should look like. Oh, one other vacuum system, vacuum operated system, I want to draw your attention to, besides the ignition, the EGR, the air cleaner flapper. Yeah, those are the main systems. Another one is the evaporative emissions system. It's a charcoal canister, and that has a vacuum source. It has a feed line to the engine that goes over to the positive crankcase ventilation, PCV valve, way on the back. That draws fumes through the fill pipe, or through the fill tube, into the crankcase. It draws air in, fresh air through it, and draws it out of the crankcase through this little valve right here. And that's fed into the carburetor. So it's got the vacuum source that controls whether it's on or off. It's got the feed going from the canister into the PCV valve, into the carburetor, into the intake system. And then it has a line from the fuel tank. Your fuel tank is vented, but the vent comes all the way from the back, all the way to the front, and the gasoline vapors are absorbed by the carbon in the charcoal canister. It also has, fun thing here, it has another line that comes from this canister up, you can follow it along, to the fuel bowl there on the carburetor. So when your engine is off, this solenoid is going to open. It's going to be closed when the engine's running. This solenoid will open, and fumes from your carburetor, instead of going into the atmosphere or going into your intake system, flooding out or over-richening your carburetor, your carburetor mix, it's going to be sucked, or they're going to make their way into the charcoal canister just like the vapors from the fuel tank. This doesn't hurt performance at all, but does keep your truck or car from smelling like gasoline. Controls all the vapors. All right, that's a quick tour. Now, time to go look at the emissions diagram for this vehicle and see what's supposed to go where. All right, you're likely to find some version or another of your vacuum routing diagram or schematic on the internet or in a shop manual, if you can't find it on the front of your vehicle. This is one that I pulled off the internet for 1987. It's just about the same, in 1989, it's just about the same as in 1987, so I use that as the basis. I erased the parts that are specific to the air injection reactor system, And that leaves me with a diagram of what should be on my vehicle. Now, that's a lot of lines, a lot of diagrams. So what I did is I broke it down into particular components. This is the ignition component with ported in blue, manifold in red, and the switched source in green. So you see, I've got a ported source here, I've got a manifold vacuum source there, and these lines go through the spark CTO, the low temp, also the high temp or heavy duty cooling CTO, before going to the distributor. There's also a very clever system that Jeep introduced in the late 80s on its AMC 360 V8s, and that's called a non-linear valve. That moderates the vacuum between ported and manifold so that the distributor is always getting at least 7 inches of vacuum. Alright, so let's go look over at these parts on the existing system of my car, see what we got. So over here we've got what they call the S terminal, the spark terminal. That's ported vacuum. That and a manifold vacuum source that should be somewhere over here. Here we go. Way deep down here is a manifold vacuum source. See that right there? I don't know if you can see that, but that tube right there is coming off a fitting that's screwed into the intake manifold, and that fitting is going to provide manifold vacuum. This for the spark system, all right in here. They go through that non-linear relay valve right there. That's what it looks like, 3 ports. It just kind of hangs out on the top of your intake manifold. Through the low temp spark CTO, through the high temp spark CTO, and then winds up, well, it should wind up right back here at the distributor. This one takes a long circuitous route through the back. Where's that going to? Ah, I see. None of that is operational on this vehicle because the previous owner, who loved to bypass everything, just put a T on this manifold vacuum source way at the back and is running straight manifold vacuum to the distributor at all times. Where do these other lines go? In this current configuration, I have no idea. So I get the fun task of figuring that all out. Let's go back. That's the first system, spark. So you can see instead of coming from this high temperature CTO, this is run all the way back to that manifold source there. Oh, that's fun. All right. That's just the ignition. I'll fix that. Easy enough. The EGR is pretty simple. That takes its vacuum source from a ported source here at the front of the carburetor, runs back to the thermostatic vacuum switch, the 5-port dual CTO they call it, and then goes through it. That provides, when it's turned on after 87 degrees or so, it goes through a thermostatic vacuum switch that's in the air cleaner, and then goes to the EGR valve with a delay valve. There's a bunch of delay valves there that will prevent the vacuum from kicking in immediately. Gives it a bit of time before it applies. And that's it. That's pretty short. That's pretty simple. That's mostly intact, I think, on this one. The next component is thermostatic air control. That is going to be the flappers over on the intake tube there on the air cleaner. One of them is closed when the engine is off so that no vapors can escape, polluting the atmosphere. One of them that opens with that manifold vacuum once the engine's running, That's the rear one over here, normally closed, open once the engine's running. This is normally open, closed once vacuum is applied to it. And again, you see it's got delay valves so that a change in vacuum doesn't suddenly slam those valves open or shut. That's what we're looking at here. So, that's the thermostatic air control with a delay valve through a thermostatic sensor on the air cleaner. This is also known for its function as preventing the intake for the carburetor from icing up. There's a thermostatic vacuum switch underneath there. Where is that? Right there. If the air temperature in the carburetor coming into the carburetor is too cold, you're driving on a 20 degree below zero day, and your carburetor is in danger of icing up, this is going to sense that low temperature. It's going to close this flap. It's going to draw warmed air from this tube that takes air from around the exhaust manifold, not from inside the exhaust manifold, and prevent your carburetor from icing up. So you can drive your Jeep under all conditions. And that's going to run directly to that manifold source and run it, be open. Well, actually, that's going to run through that thermostatic vacuum switch inside the air cleaner and close if it's cold. All right, that's it. That's it for that one. The EVAP PVC system. That's that evaporative system with the charcoal canister. And that has a signal line from the dual temp CTO. It also has the lines sending vapors in various directions. You can see the PCV air in comes from the air cleaner through the fill cap. That's what this little tube here is doing, is drawing air into the crankcase. And it draws it out of the crankcase through the PCV valve. And it also is drawing fumes from that charcoal canister when the engine's running. It's drawing the vapors into the engine and burning them rather than emitting them to the atmosphere. Those are larger tubes. And the power valve, on this particular year of the 2150 Motorcraft carburetor, the power valve is activated when manifold vacuum is low. So there's a manifold vacuum source from the back of the engine that feeds this valve in the front of the engine. That is right down, and you can just barely see it there at the very bottom of the carburetor. When that goes bad, when the diaphragm there goes bad, it leaks gas into this line, and you start running very rich. Or, alternately, if that line cracks, that's going to prevent the power valve from kicking in when you need extra gasoline under load, and you're going to feel a loss of power. So that system has to be intact and running. Most cars have that vacuum routing inside the carburetor itself. Not the 2150. Some years of the 2150 do, this one doesn't. It originally was drawn from, in earlier years, from this manifold vacuum source there. For whatever reason, perhaps to buffer that vacuum signal so it wasn't always so direct. In 1986, Jeep switched from a front source to a rear source and sent out a technical bulletin instructing its dealers to change the routing of the source from this local vacuum port to this rear vacuum port, giving some buffer there of the vacuum signal in that line. And finally, what size hoses do you buy? All those hoses are different. Most hoses go in 30/2 of an inch. So, 5 32nds, 7 32nds, 9 32nds, and 11 32nds. Those are the most common sizes for these vacuum lines. There's also, on this one, 3/16 line. Now, if you look up the part manual for a Jeep, it will tell you certain lines are from bulk rolls, and they give you the part number, which you can Now, there's not many sources to find out what that part number corresponds to in standard vacuum sizing, but I figured it out for this one. All the lines from the purge signal for the PVC system, those are 5/30 seconds. That's a very common line. All the lines for the air cleaner, the thermostatic air control, those are all 3/16. The power valve takes a 7/30 second, and there's a tiny bit, this line here that goes to the fuel tank is 9/30 second. That's the one I labeled in pink. Now what I got to do is figure out all this system here for the distributor. Yeah. The thing is, this system has been played with, you can't tell how much, so I don't know exactly what is supposed to be and what's not supposed to be there based on what's on the engine. It seems to be a combination of two different sizes, but there's a mixture of the old AIR air injection reactor system that runs off that dual CTO, which involves these very small lines here, right? Smaller than 5/30 seconds. And it's also a mix of, and you can see it on this one, here's the it's smaller than 5/30 second, probably 1/8 line, maybe 3/30 seconds line. And here's the 5/30 seconds line on the other side, running on this vacuum delay valve. Well, what am I going to do? I'm going to take the whole thing off. I'll take off all that vacuum harness, which is easy because these connectors just disconnect at the vacuum port. It's very handy. The vacuum harness was assembled from Jeep, and they just plugged it. The Jeep workers didn't have to plug each thing in. They just had to plug these little harness connectors, these molded plastic vacuum lines, onto each of the switches. Well, I'm going to take this apart. I'm going to reroute everything the way it should go. Then, in order to do that, I've got to see what size I need to buy. So hang in there. We're going to take it all apart.